In the previous video, we created a simple Lambda function using the serverless framework and Python. Now we will create a more complex service, similar to the one that we created in the Volume 1 videos using Node.js, but this time we will use Python. In this video we are going to refactor the Lambda function from our previous video, then we will add DynamoDB for data persistence, we will create the other CRUD operations, and then we will test our deployed service using Postman. I'm back at my Atom editor where we left with the last video. I'm going to refactor the handler function a little bit. For example, I'm going to replace the body with a short message, created new article, and here I'm going to print out the event that the Lambda function has been invoked with. Also, instead of naming the function handler hello, I'll simply rename it to handler. Now what I need to do, and I'm also going to delete this down here, what I'm also going to do is I go to this serverless YAML file, and here I need to rename this from hello to handler. And now it's handler.handler, and I don't like that so much, so I rename the handler.py file from handler to create. Now I'm going back to the serverless YAML, and I call this create. And here I'm also calling this create. Next, I want to give my Lambda function an IAM role that enables it to perform certain DynamoDB operations. So I'm going to replace this code, this commented code down here with the following IAM role statements. And please be aware that this syntax is supposed to change from Serverless Framework 1.8 upwards. So when that happens, please take a look at the source code in my repository. I'm going to update this code as soon as possible in the tutorial. So please check that out in case it doesn't work with your version of the serverless framework. What I'm going to do here is I give my Lambda function permission. I allow it to perform certain actions, query, get item, put item, and so on the following resource, and you should replace this with your own resource. So you need to go to the AWS Management Console after your DynamoDB table has been created, and make sure that that this is the resource ARN. I'm going to show you in a moment where you find. What I also want to do is I'm going to scroll down in my serverless YAML file, and down here I can create additional resources using a CloudFormation resource template. And here I'm going to create the DynamoDB table that I will give my Lambda function access to. The table name is PyBlock table, and it has one hash key, article ID, which is of type string. And this is my hash key, and here I specify the capacity units, the throughput that I provision for my table. The minimum settings is 1 for read and 1 for write. The higher these settings, the more throughput you get, so the more concurrent requests you can make on your DynamoDB table, but also the higher your costs. For our simple application, 1 and 1 is fine. So after you have set that, let's just here in the function add this event, an HTTP event, and instead of a get method, let's make it a put method, because this is a create operation. And here, by specifying this, we will, by performing an SLS, a serverless deploy, we will also create the appropriate API endpoint using API Gateway Service. Now I have opened my terminal, and I'm going to do an SLS deploy. Okay, the service has been deployed. We can invoke it. The service has been deployed and we can invoke it via SLS invoke, and this will invoke it remotely. And the function name is create. And this returns the message, created new article. Actually, it didn't do anything. It's just a stub right now. More interestingly, let's head over to the AWS Management Console and see if our DynamoDB table has been created. I'm now logged into my AWS Management Console. Here I'm on the DynamoDB dashboard, and as you can see, the PyBlog table has in fact been created. If I click on it, I can see some additional information. I have a hash key or primary partition key of type string. And there are, of course, no items in it yet because we haven't added any items to the table. But what you can also see on the Overview tab, if you scroll down, is the ARN. And this is the string that identifies your table as an Amazon resource. So copy that and paste it here in your serverless YAML file in the AIM role statement. So the AIM role statement gives your Lambda function permission to perform the following actions on this resource. And this is the resource that identifies, that specifies your DynamoDB table. So now we have created a DynamoDB table and our Lambda function has permission to access that table. But actually, if we take a look at the createPy function handler, it doesn't really do anything yet. So I'm going to replace the code with the following. What I'm going to do here is I import the Boto library as said before. This is globally installed on the instance that executes your Lambda function, so you don't need to install this dependency. You can simply import it like this and then use it, for example, here to instantiate a DynamoDB client. On the DynamoDB client, we want to access the PyBlog table. And since we are going to create a new item, we are going to create a UUID here and then prepare a table put item request with the following item content, an article ID with our randomly generated UUID, and the following hard-coded text. And this will return the following put response, which we are going to print out on the console and also going to play back in our response. Okay, let's do an SLS deploy to update our service and then test if it works. I have deployed the service and now I'm going to use a synthetic dummy event to test the Lambda function. In my directory, I'm going to create a new file, event.json, the following content, and then I'm performing an SLS invoke with the create function and specifying the path to the event.json file. Now this has done something and it looks quite good. Let's head over to our AWS Management Console. I'm here on the DynamoDB dashboard. And if we look at the items, a Hello Python article has been created. I have just copied the other read, update, and delete Python Lambda function handlers into the directory, and I have updated the serverless YAML file. So if we scroll down a little bit, besides the create function handler from before, here I have also changed the path a little bit. So instead of create, it now says articles. Here for the read handler, I have the path article and I give it a path parameter, the ID of my article. I can perform put operations to update the article and I can perform delete operations to delete articles. and the rest is as before. And I have added the respective function handlers to get items from my DynamoDB table and return them in the response, to update articles in the DynamoDB table, and to delete articles in the DynamoDB table. I've also added this path parameter to my event.json file so that I can also test the read article function handler. Let's deploy the function and test the API using Postman. For testing the API, I'm going to copy the following endpoint, and then I'll open Postman and I'll use this endpoint. I've opened Postman, I've selected the post HTTP method, so I'm going to create a new article. Here I have pasted the endpoint from before, and here I add as a payload the following JSON file to my post request. Then I click send. And this will return the article ID of the article that has been created. I'm going to copy that and perform a GET request. And this returns the text that we have just created with our article hello from Postman. That's it for section 2 of volume 2. Here we learned how to create Lambda functions from blueprints on the AWS Management Console using Python. And then we used the serverless framework with Python to create a little more complex service that includes Lambda, API Gateway, and DynamoDB. In the next section, we are going to program AWS Lambda using C#. See you there.